Hello everyone, I am Dr. P.S.V.Shanmukhi, Associate Professor, Department of Physics, Aditya University. Now I am going to explain about the quantum free electron theory of metals. Quantum free electron theory of metals. At the end of this lecture, student will able to understand the success of quantum free electron theory, and he can also derive the expression for the electrical conductivity of metals. Coming to the quantum free electron theory, actually according to this quantum free electron theory assumes every metal contains large number of valence electrons. Actually they are free electrons. Those electrons can move freely and randomly. The quantum free electron theory was proposed by Sommerfeld. So it was proposed by Sommerfeld. Actually classical theory failed to explain many properties of metals. To overcome those drawbacks, Sommerfeld proposed one free electron theory, that is quantum free electron theory. As per this one, every metal contains large number of free electrons. They are called electron gas or free electrons. Actually the collision theory is completely ruled out in the quantum free electron theory, and of course these free electrons actually they are moving freely and randomly. But as per the quantum theory or de Broglie hypothesis, each electron is regarded as an electron wave. Suppose this is the distribution of free electrons among various energy level as per the FD law. But according to de Broglie hypothesis, each electron is treated as an electron wave or de Broglie wave. What is the de Broglie wavelength? The de Broglie wavelength is given by lambda is equal to h by mv, that is the de Broglie wavelength. But actually to locate all these kind of electron waves, ordinary coordinate system is not at all suitable. We need a special coordinate system in a special space. I will explain it. Before that, actually this quantum free electron theory successfully explained the variation of specific heat capacity in case of metals. It is able to explain the heat capacity in metals. It is able to explain so many other phenomena of metals like photoelectric effect, Compton effect, black body radiation, and also it would able to explain the ferromagnetism, antiferromagnetism. All those things were successfully explained by the quantum free electron theory. So as just now we have discussed, suppose say these are some electron waves. To locate such kind of electron waves, ordinary coordinate system is not suitable. I just take one special coordinate system with a special axis. Those axes are kx axis, ky axis and kz axis in k space. This is the k space. Now by enclosing all these electron waves, we get a sphere, that is called k sphere or Fermi sphere. The surface of the sphere is constructed by the Fermi electrons. Actually if you observe, these are the electrons among various energy levels. The uppermost field energy level at T is equal to 0 K is called Fermi electrons, or this is the Fermi energy level. Those electrons are the Fermi electrons. Therefore, the Fermi electrons lie on the surface of the sphere. Now constructing the sphere means enclosing all these electron waves, it will constitute a sphere called Fermi sphere. The surface of the sphere is constructed by the Fermi electrons. The radius of the sphere is given by kf. It is the wave number vector of the Fermi electrons. It is a special concept, means all these electrons are taken in a space, that is called k space. What is k in this one? K is equal to 2 pi by lambda. That 2 pi by lambda, k is called wave number vector. Wave number vector space, where lambda de Broglie wavelength, 1 by wavelength is the wave number, or k is called wave number vector. So that kind of special space is taken. Here as usual, suppose this is a metal, it is connected to a battery like this. So automatically electric field is acting in this direction. Therefore there are some electrons here. These electrons will experience some force. They are attracted by the positive terminal. So what is the force acting in this one? F is equal to E into E. Due to the application of the electric field, the force experienced by the electrons, F is equal to E into E. As per the Newton's second law, F equals to ma. That means F is equal to m into dV by dt. So from these two equations, what we can write? E into E is equal to m dV by dt. Therefore, dV is equal to E by m into dt. Here you observe one thing. Due to the application of the electric field, during the time interval dt, there is a change in the velocity dV. The change in the velocity, it is due to the application of electric field during the time interval dt. Even though there are some electron waves, still we are taking the change in the velocity in the time interval dt because of the applied electric field. Just observe this de Broglie wavelength, lambda is equal to h by mv. What is k? K is equal to 2 pi by lambda, or lambda is equal to 2 pi by k. Substitute here, what do you get there? H by mv is equal to 2 pi by k, or v is equal to h by 2 pi k by m. And afterwards, what is v? V is equal to h cross into, say that k by m, or take the variation in v. Just take the variation in v. dV is equal to that h by 2 pi is taken as h cross or h cut. In quantum mechanics, we are taking h cut by m into k. We are taking like this. So h cut by m into dk. The change in the velocity causes the change in the wave number vector. Simply, when you apply the electric field during the time interval dt, there is a change in the velocity. Because of the change in the velocity, wave number vector also changing. Suppose the number of waves that is also changing because of the applied electric field. Okay, keep it aside. Now you just observe, in case of 3-dimensional system, this is a sphere. But in case of 2-dimensional system, the region enclosing representing a circle, only two coordinates are required, that is kx axis, ky axis. Whereas in a 3-dimensional system, kx, ky, kz we have taken. Now, at T is equal to 0 degree Kelvin, when there is no applied electric field, E bar is equal to 0, the center of the circle, origin of the coordinate system are coinciding. When the electric field E bar is applied, E bar electric field is applied, what happens? The entire circle or entire sphere moves in the opposite to the electric field direction. So you observe the entire region is moving. Okay, because of the change or the movement of the electrons, there exists some current or current density. What is the current density formula? J is equal to Ne into, actually we take V suffix D, drift velocity. Actually the drift velocity, it is the average velocity between two successive collisions, or it is the average velocity we just take. The average velocity because of the application of electric field. Here there is no collision theory in the quantum free electron theory. Only in the classical theory we talk about the collision theory. That's why I don't want to take this Vd. I want to take only dV, the change in the velocity. J is equal to Ne into dV. Therefore, you substitute Ne into what is dV? Already dV you have determined. Equation number 3 you observe E by m into dt. Substitute the same thing here. We get this one Ne into E by m into dt. Finally, what we are getting? So, J is equal to Ne square by m E into dt. Actually, J by E is called conductivity sigma. J is the electrical current density, E is the applied electric field. J by E is called conductivity sigma. What is the equation then? Ne square by m into dt. This is the expression for the electrical conductivity according to quantum free electron theory. But one thing, if we take the classical free electron theory and there we take the electrical conductivity expression, then we get Ne square by m into tau, where tau is called the mean time. You observe that equation 5 and equation 4, there is no much difference between these two equations. Ne square by m into dt, time interval, Ne square by m into tau, tau is the mean time. Mean time is the time between, the average time between two successive collisions. Then what is the difference between the classical free electron theory and quantum free electron theory? In the electrical conductivity expression, there is no much difference, seems to be like that. But you observe this equation, this diagram, before before and after applying the electric field, some region is there like this, electrons are there in the same region. But after application of electric field, only small portion of electrons are contributing effectively. Observe, according to the classical free electron theory, all the free electrons participate in the electrical conduction. All the free electrons participate, but according to quantum free electron theory, only the electrons nearer to Fermi surface, electrons on the Fermi surface can effectively participate in the electrical conduction. Other electrons cannot participate in the electrical conduction. This is only the major difference between the classical free electron theory and quantum free electron theory. That means surface electrons are only participating in the electrical conduction. Actually, this theory successfully explained all the properties of metals like photoelectric effect, Compton effect, black body radiation, and also other phenomena like ferromagnetism or antiferromagnetism, ferrimagnetism. All the things were successfully explained by the quantum free electron theory. Coming to the summary of this one, actually in this one we have seen what are the success of the quantum free electron theory, how it is able to overcome the drawbacks of classical free electron theory, and finally we have seen the expression, we have derived the expression for the electrical conductivity of metals. We will be able to explain the electrical conductivity of metals successfully. Thank you.